going to dive right into that 8.1 problem. Suppose that consumers see haircuts as an undifferentiated good, that there are hundreds of barber shops in the market, that the current market equilibrium price of a haircut's $15. Bob's barbershop has daily short-run total cost of that function, and the associated marginal cost is that. How many haircuts should Bob give each day if he wants to maximize profit? So, maximize profit. How do we start this one? What's going through your brains right now? No. But I liked your first part. It would be the quantity where something happens, the thing that I tried to burn into your heads in principles class about the profit maximizing condition. I thought you were going to roll right off your tongue, and then you went to the place where average total cost is minimized. That's what's going on there. So that's true. And by the way, that might be the end result under certain circumstances. But our general profit maximizing condition. Colby, what are you thinking? Not thinking? Adam? Jesse? So, what is the, go ahead, Blake. Price times quantity gives you what? Revenue. So let's get back to the basics here. So we are trying to maximize profits. Profits are equal to total revenue minus total cost. Okay. So what are we trying to do? So to maximize profits, a firm should produce the quantity, where, this is where I thought Taylor was going to nail it, and then it didn't happen. Total revenue is the highest. No, because we want to maximize profits. Now that would be true. You'd want to maximize total revenue if what? If we want to think about this condition. If what? If total cost was minimized or fixed, maybe. Then we'd want to maximize total revenue if total cost was fixed. So if all costs were fixed, then you'd be in a revenue maximization mode. But in our most general case, are costs fixed? Are all costs fixed? No, there's variable cost in there. So as we produce more quantity, what happens to costs? Do they go up or down? As we produce more quantity, costs go up, right? So the upward sloping marginal cost curve, or even if marginal costs were constant, costs would continue to go up. So we have some sort of positive relationship there for if we have quantity and we were measuring total cost, it's some sort of positive relationship, upward sloping. So that's going up with quantity. And then what's happening with revenues with quantity? I'd agree with you for a while, but then it's possible that revenues could be it is increasing at a decreasing rate usually. Our general revenue function was that humpy thing if the demand curve was downward sloping. So we're always trying to think of these two things kind of how are they working together. Revenues are going up at a decreasing rate. Costs might be going up at an increasing rate. And so the bottom line is we don't really know for sure what the interaction of these two functions are going to be until we have more detail. Now we've got more detail. So with this problem, we've got a marginal cost function, we've got a total cost function, And we can still come back to our principles class lesson here. To maximize profits, a firm should produce the quantity where we've got marginal cost, marginal revenue, there we go, that's the word I wanted to hear, where marginal revenue equals marginal cost. The revenue generated by the last unit produced is just equal to the cost of the last unit. That's our profit maximizing condition. All right. Now with this particular problem, we're in the perfect competition environment. What can you tell me about revenues? They give us marginal cost. So they say, from the problem, we know that marginal cost equals Q. You produce 10 units, you got 10 bucks worth of cost. You produce 100 units, you got 100 bucks worth of cost, right? So marginal costs are equal to Q. What about marginal revenue? What does the marginal revenue function look like for this company since it's operating in a perfectly competitive environment? What are the characteristics of perfect competition? They kind of hint at them in what they say in the words there. But we went over kind of 3 primary driving characteristics of perfect competition. What's that? No barriers to entry, so free entry and exit. Good, that's one of them. Anybody remember the other ones? Again, you can kind of read that problem and get hints as to what they are. Yes, a large number of competitors. Everybody's a drop of water in the bucket. All firms are basically insignificant to the overall market. And then there's one more. The same product. So basically identical products, homogeneous product. So all haircuts are perfect substitutes with each other. So then people, of course, would just flock to the cheapest one if they're perfect substitutes and they're rational, right? Okay, so that's the 3 characteristics of perfect competition. And so what is that going to imply for the revenue generated by this firm? What is the revenue of one more haircut going to be equal to? Just the price, that's right. So just the price. So the firm is a price taker. So marginal revenue equals price, the market price, in perfect competition. In perfect competition. The firm is a price taker. Remember that now? After we shake out the cobwebs a little bit here. The firm is a price taker. The graph that we fall back to model perfect competition is the one where you put them both side by side. You've got the market represented here with a downward sloping demand and upward sloping supply, just like chapter 2 or 3, whatever chapter that was. And so we've got the big market, let's call it for corn. So ag products are something that's similar to perfect competition. And then over here we have the representative barber, the representative firm, the representative farmer, Farmer Tom, Farmer Dick, Farmer Harry, a drop of water. One of these drop of waters in the bucket is over here, and we're measuring the quantity for that particular firm. And because of the characteristics of the market of homogeneous goods, large number of sellers, right, free entry and exit, whatever price comes out in the market, if corn is clearing at $5 a bushel, then our farmer Tom can produce 100 units, 200 units, 300 units. What's the price he's going to get if he gets 100 units? He's going to get $5. What about 200 units? He's going to get $5. 300 units, $5. Why? Because he's powerless. He doesn't have any impact on the overall market. There might be 1 million bushels of corn here. He's just providing 300 of them. Big deal. So the demand curve for Farmer Tom's corn is perfectly elastic. Perfectly elastic. Now, if Farmer Joe is producing 100 bushels and he says, wow, what would I get for the 101st bushel? I'm going to get $5. So what is the revenue generated by the 101st bushel? Blake? The same as the price, right? So the revenue generated, now I'm going to put those in red here. The 101st bushel brings in $5 more worth of revenue to my firm. The 201st bushel brings in $5 more revenue. $5, $5, $5. The marginal revenue curve and the demand curve are really one and the same. Demand is equal to marginal revenue for the price-taking, perfectly competitive firm. All right. So back to our problem. Solve it out. What do we got? What's that? 15. Right? So this one kind of collapses down. They've got it pretty simple here. So price was equal to, grab a orange or something. So they told us the market price was 15. So if we set marginal revenue equal to marginal cost, we get quantity of 15. Just the way this thing collapses down. Again, it's almost too simple. It makes it kind of difficult to see. Part B then, if the firm maximizes profits, how much profit will it earn each day? What is the profit going to be? What is the profit going to be? No, I jumped to B already, so yeah. So set it up. Marginal revenue. Marginal. Go ahead and write that all out though for part A. So marginal revenue equals marginal cost means that marginal cost was given to us. Write out part A better. I know you guys were kind of listening to me, but I'm not seeing on your papers what I would give you full credit for on an exam. So make sure you write out the profit maximizing condition. And I would even go a little bit further. You're pretty good. What is that? D equals, oh, D equals marginal revenue. Price, marginal cost. Yeah, you're probably okay. You might, yep. Yes. And again, it collapsed down so easily, but the marginal revenue of an additional unit was 15. So setting those two equal to each other, it just collapses down to 2 equals 15. Real important that you guys see that. We'll have a little bit more complicated stuff later. This is just kind of a get us started thing here. What did you get for profit?
I don't know.
Okay. So you're still working?
Yeah.
Who's got a profit number? So that's total revenue, but I'm looking for profit. So you've got a total cost function. Taylor, did you get it? Something? Okay. Yep. So, again, show all your work, put profit equals price times quantity, maybe even write out 15 times 15 minus total cost. You're going to be substituting that function in. Yep. Okay, good, but I don't like the way you showed your work. So, that's your cost function, right? So here's what I want you to do. I'm going to do it for you this time. So you start off with a problem. Profit equals total revenue minus total cost. And then just keep following your logic all the way down. So price times quantity minus the total cost. 15 times 15, right? Price and quantity minus my total cost function, 0.5 q squared. And then, well, this is to the 15 squared like you did there. And then that equals whatever it equals. I would actually show your work here on the 225 minus that. Okay. So yeah, this is what you need to be doing. And it's okay to chunk it apart like this, but kind of like what I did with Blake, is to maybe just keep showing it this way. Price times quantity minus total cost. And this is now 15 times 15 minus, what is it, 0.5, 15 squared. And now you've showed everything really in a nice package where I can look at it and say, Colby knows what the heck he's doing. And he did just get lucky. Okay, good. All right, so 112.50, looks like you guys are all on the right track, is the amount of profit. Now to extend this just a little bit, what was the story of profits then? If there's economic profits of 112.50, what's going to happen in the market? What would be your prediction as to what would happen? More firms are going to enter the market. And when that happens, what happens over here? Supply increases. So we start to get the supply curve shifting to the right, causing price to fall. Supply is going to continue to increase until profits are 0. Now, just to tie this back since you brought it up, Taylor, the long run situation is what we just described, where profits are going to be equal to 0. And that happens when average total costs are minimized. So if and we're probably going to do this on the next problem, but this might just serve as good a purpose as now. So if again, I'm not drawing this to scale, but if this was the average total cost curve, this price is going to keep falling, right? Because of the supply increase, the price is going to keep falling, and where profits equal 0 is at that point. That point happens to be where average total cost is minimizing where marginal cost is equal to it. Okay? So that's where we'll come back to that, is the kind of the long run prediction for perfect competition. All right, any questions? That's where profits are 0, yes. And I think we're going to get to that here, maybe even in this next problem. So flip it over, 8.2. Cardboard boxes are produced in a perfectly competitive market. Each identical firm has a short-run total cost curve of that, where Q is measured in thousands of boxes per week. The firm's associated marginal cost curve is that function. Calculate the price below which a firm in the market will not produce any output in the short run, i.e. the shutdown price. Oh boy, we're getting thick fast here. Do you guys remember the shutdown concept? There was one special case where the firm would not be following the MR equals MC rule, that they'd actually be better off producing 0. Not going out of business, by the way, but just shutting down, producing nothing, and just paying their fixed costs. What was that condition? That's a tough one. Might be worth an extra credit point if anybody pulls it out. It will be worth an extra credit point if anybody pulls it out. When is it better to shut down? Hearing none. Okay, I'm going to go back to this picture just to beat it up a little bit more. No, it has to do, it's related to fixed costs, which may be, well, that's not true. They're not sunk. Sunk is gone for good. Well, no, some could be in there, but the average variable cost here is missing, right? So if I drew in an average variable cost curve that looked like this, what's the relationship between average variable and average total? That's right. So the difference between average variable and average total is the fixed cost. So our formula for average total, which is a part of that bigger formula that we had, average total cost is equal to the sum of average variable and average fixed cost. And that is the vertical distance between the two. So as you graphically draw this, the vertical height shrinks as you move up this way, because the distance between here and here, the vertical distance, is the average fixed cost associated with producing 322 units. All right, so that vertical distance is the average fixed cost. In other words, at 100 units, the variable cost is this number, maybe it's $2, and the total cost is the total cost is $4.80, and so there must be $2.80 worth of average fixed cost at this quantity. All right. Questions on that? So, if we are using the profit maximization rule and the demand curve is shifted down to here and we're at $1.50, and so if the demand, I should almost draw a new graph, but if the demand curve is down here at $1.50, the profit maximization rule of MR equals MC says that you should be producing 110 units. If you say that again? That's kind of a loaded question. You can kind of ignore that for now. But there's two spots. It does actually go across that. That's right. But you'd want to be at the higher quantity, I guess, long story short. So at this price, marginal revenue equal to marginal cost would say produce that quantity. But the average fixed cost is this distance. And so you will lose less money. You will lose less money by producing nothing and just pay your fixed cost. So the losses that you'll incur at this production level are greater than what they would be if you just paid your fixed cost. That's the shutdown concept. Let's just start working through it if it's a little fuzzy on you. That was kind of a quick principles rundown of the shutdown. So the real, before we do though, let's put the real profit maximization problem. In full glory, a firm maximizes profits if, or I don't even want to say if, where, or by producing Q star, where marginal revenue equals marginal cost, if price is greater than or equal to average variable cost, or by producing nothing if price is less than average variable cost. So drawing a quick new picture, what we've derived is the supply curve for the firm. Oops, search total. want you guys to get caught up before we look at this the last time here. So marginal cost curve always cuts through the minimum point of the average total and the average variable. Now, I've left off this part of it here. We're going to be thinking about market prices. So at a price of $10, if the market price is $10, the firm should produce Q1. So if P1 equals 10, Q1 equals this. If we drop down to P2, we produce Q2. If we drop down to P3, we produce Q3. Now, what's the difference between, let me drop down to P4, if price falls down to this range, and we produce Q4 using the profit maximization rule, what's the difference between P3 and P4 at those two prices? What's happening in terms of profit? There is a difference in fixed cost, by the way, but what are the profits at P3? If prices are P3, maybe $6 according to my numbers here, $6.10, what are profits? You want to say the right answer. Yes, that's right. So there's 0. So price equals average total cost. So at P3, the price equals the average total cost per unit. So there's 0. No economic profits. Once we dip down into P4, the firm's incurring a loss. Above P3, we had economic profits greater than 0. Now, if we fall down here to P5, the firm should produce Q5. And what we've generated is the supply curve. So the marginal cost curve is the supply curve. If we go back to chapter 2, what's the supply curve? It's a relationship between prices and the quantity supplied. The marginal cost curve is the supply curve. Except when prices fall below P5. Because now, if we go to P6, the profit maximization rule to say to come out here, but it turns out you're going to be losing more money than you would if you just produce nothing. And at every price here. So the supply curve is discontinuous, and it makes a jump down price. So P5 is the shutdown point, or the shutdown price. At all prices below P5, we're better off producing nothing. So the squiggly line here is the supply curve. All right. So how far are we on this problem? Part A, that's the background that you guys already came into this class knowing. So, yes, Colby.
I have a question. So below P3 is like profit is less than 0, or there's no profit?
That's at P4. It's a loss.
Okay, so why wouldn't you why is P5 the shutdown?
Okay. Let me show you it this way. At the shutdown price of P5, the remember the demand curve would be shooting through here. And let me just go ahead and draw a full demand curve. There would be the demand curve equal to marginal revenue. I didn't draw all of those in so that we kind of knew where we were going. The loss would be the price minus the average total cost, right? So profits are equal to price minus average total cost times quantity. That's a variation of the profit formula, right? We can do this one, the difference between price and the average total cost. The price is P5, whatever this number is. The average total cost is up here. So here's the average total cost at Q5. And so this represents the economic loss. That's what you're kind of wondering? Now, it also represents something else. If you guys are really getting this,
Is it because you don't need more fixed costs? Because you said the difference between...
it's not that we don't have them, but this is equal to them. Because this is the vertical distance now between average variable cost and average total. So this green box is also equal to your fixed cost. And so when we move down here, if you end up working real numbers, the loss is bigger than the green box. And so you're better off producing nothing and just paying the green box the loss. Okay? So that's what makes the shutdown. All right, let's hit this problem. So, this is all just one part. Okay. Calculate the price below which a firm in the market will not produce any output in the short run. In other words, calculate the shutdown price. What do we need to do now that you're armed with this information, but yet we don't have the graph here, we only got equations? What do we need to do? What equations do we have? Marginal cost and total cost, right? So what can we do? You're on the right track, but we want to modify it before we move forward. We need to kind of really follow what's going on graphically here. So we've got total cost. I'm just rewriting what the total cost function is. So rewrite this on your papers. We got Q3 minus 18Q squared plus 30Q plus 50. That's the total cost function. What do we really need? Okay, average total cost, is that to find the shutdown point? We need the average variable cost to find the shutdown point. So let's look for before we get to the average variable cost, let's look for the total variable cost, right? What's the total variable cost function? Everything except for this guy, right? So there's your variable cost function. Total variable cost. Here's your total fixed cost. Average variable cost equals total variable cost divided by quantity. Do it. Alright, so Colby and Blake, I see that you're not writing everything out, you're in big trouble. Good. Okay, I'll finish that one out. You're kind of in big trouble. Well, maybe you're not. Okay, so you wrote that out. So you got, okay, so you wrote that down. That's the total. Okay, yeah, you're modifying. So don't copy. You should work that. I probably wrote it up on the board too soon. How are you doing? All right. So now what? Good. Set average variable cost equal to marginal cost. We're just following this graph exactly, right? Marginal cost cuts through average variable cost. Solve for quantity. Okay, try to find you're off by just a little bit. Find your, I gotta walk around anyway. Did you find it? Yeah.
Yeah, I didn't mark it very.
Okay, yep, that looks good. So yep, and then solve for Q. Yep, yes. So then write both of those out. Set them, oh, that and that. Okay, yeah, and then solve it out for Q.
Would it be better for her, like,
Yeah, start up there, yes, that's right. Yep, start up there and then follow down. Put the equal sign too, yep.
Kind of stuck.
Okay. Okay.
I tried to factor out a Q, and then I was like, I don't know where to go from there.
Keep work. So you can simplify that down a little bit if you put them on both sides.
Oh, on both sides?
Yep. Don't be afraid.
Okay.
To solve, just kind of keep working, dividing. Get it?
Yeah.
Now we can get rid of one Q. Okay, that's fine. Get rid of that Q. There you go.
Oh, okay.
Okay. All right, now you're not done yet. You got to find the shutdown price. So Q equals 3. It looks like you guys all got that. So Q equaled 3. But the question asks for calculate the price below which the firm will not produce any output in the short run. So what is the shutdown price? In other words, you're looking for this little guy right here. you found this guy. You need to find this guy.
How do you get rid of the Q?
How do you, oh, you guys haven't got, so, to get rid, you were okay there. Yeah, leave that. So you need to get rid of this Q. So divide by Q. What you do to one side of the equal sign, do the other, and it just Q equals 3.
Use the perfect combination thing. Like a first problem wasn't the last one, so would it just be 3?
No. Well, you got the right answer, but it's not, I don't know if you said it the right way. So it is that, but how are you getting it?
Because price equals marginal revenue, which equals marginal cost, equals quantity.
Yeah, but we didn't have that, did we? Yeah, we didn't have that information. How did you get that?
I don't know.
Oh, it's not related to that problem.
I know, I just used the formula that you used, you said marginal
From the
revenue.
previous problem.
Yeah, I didn't know, that's why I asked if it was a per competition like it was last
Oh,
time.
no, it's not. That's a different thing. So you need to solve this. You know that this is Q equals 3. And you need to substitute it into something. Tell me what you're substituting it into. Okay. Yes, that's true, right. And maybe that's what you're, is that what you were saying, Adam? I didn't know if you substituted it in.
Didn't we technically find the marginal cost equal 3 equals Q?
No, you found the quantity that the firm will shut down at. So all you've solved for at this point is Q equals 3, that this is the shutdown quantity. Now you need to find this shutdown price. So you need to substitute it back in to something. And you actually have a couple choices. Taylor, what'd you do? Plugged it into the average variable cost curve. You could also plug it into the marginal cost curve, which might be a good exercise. But it didn't just equal 3. But is that what you did mentally? I don't know if where you came
No,
up.
I really just did it
From the previous. Yeah. That was total luck. So we don't want that would have caused you to be wrong on applying it later. So yes, you can substitute it back into the average variable cost function or the marginal cost function. And then that either way will get you $3. So the answer just happened to be 3. Yes. Okay, so 8.3. We got the pickle industry. Assume that the pickle industry is perfectly competitive and has 150 producers. 100 of these producers are high-cost producers, each with a short-run supply curve by that. 50 of these producers are low-cost producers with a short-run. Prices are in dollars per jar. Derive the short-run industry supply curve for pickles. Short-run industry supply curve for pickles. So, thoughts on that? Yeah, so the industry is composed of low cost and high cost. Conceptually, what we're thinking about is maybe I'm just going to give you a little bit general thing here. So we got a producer with a supply curve like this, one that looks like this, one that looks like this, one that looks like this. So there's a bunch of different supply curves. And at this price, with price equal to marginal cost, at $10, this guy's going to bring 3 units, this guy's going to bring 7 units, this guy's going to bring 5 units, this guy's going to bring 4 units. 3 plus 7 is 10, plus 9 is 19 in the market, right? So that's kind of how the supply curve is generated, the market supply curve. So if this is the market, that's kind of conceptually how it's going. the supply curve is equal to the sum of the individual marginal cost curves. Let me write that a little bit better here. The supply curve is equal to the sum of the individual marginal cost curves. Another way we did that in principles class was to think of that the market quantity is equal to the sum of all the individual suppliers. We're adding them together. All right, so we got some supply curves, right? How do you want to tackle this one? Okay, we can add them together. Now there's 50 of them in each one, right? Or 100, oh, 150 producers. Oh, right. Okay, I forgot about that. All right, yeah, they're disproportionate. So 100 of the high cost, 50 of the low cost. So set up a function that describes that. We've got the high cost people equal to what, 4P? Is an individual firm's, and I would put like a little q here. Little q equals, that's one firm's supply function. The low cost producer is 6P. And so you're right, you want to add them, but then you also need to take into account that there's 100 of one type and 50 of the other. Yep. Yep. 700p, that sounds right. All right, so big Q of the high cost equals, there's what, 100? 100 times 4p? And big Q of the low cost, guys, is 50 times 6p. Add those two together to get the whole market quantity of big Q for, what's our industry? Pickles? So the quantity supplied of pickles in the industry is equal to 700. I'm skipping a few steps, but that's right, 700p. Okay, if the market demand curve for jars of pickles is given by that equation, what are the equilibrium market price and quantity? So now we're right back to a supply-demand deal. We've got 6,000 minus 300p. And how many jars? 4,200, yes. So just, what's that?
You just said that equal.
Yep, set that equal. And then you need to solve for, so if you set them equal, you're going to be solving for p. And then sub p back into one of the equations, yes. What'd you guys get for p? 6. Quantity equals 4,200, you said? That's correct. At the price you found in part B, how many pickles does each high-cost firm produce? How much does each low-cost firm produce? So they're both price takers. Let's see, high costs are, right? So we got 6 times 4 is 24 is the high cost individual firms. So little q for high cost firm is 4 times 6 equals 24 units. And the low cost firms are 6 times 6 equals 36. Alright, and then the big one, producer surplus. So part D, producer surplus. What is the choke price? That's kind of the catch here. We've already got that information. So we know that there's a supply curve that looks like this. $6 and 4,200 is the industry. So producer surplus. So what we don't know is what the choke price is. Or do we? Nope, we're making it more difficult. It's a what, Jesse? It's 0 because at a price of 0, the quantity is 0. It starts at the origin. This was just kind of a simple one, but I just wanted to call that to your attention that we don't necessarily know that, but it happens to be 0. And so now just calculate the area of that, 1/2 base times height, back to our producer surplus. So 6 times 4,200 divided by 2. 12,600. So producer surplus is 12,600 bucks. Okay, learning curve, chapter 6. And I'm chapter 8, yes. Yes. We don't want to work backwards. So learning curve, chapter 8. Your back of the chapter problems we will be due on Wednesday morning. So if you want to get a jump start, if you're getting in the groove and you kind of want to do both, that'll be due after that. So
They're both due.
no, learning curve is due before class Monday.
Okay.
So make sure you hit the learning curve for chapter 8. But then the back of the chapter problems will be due Wednesday morning. So if you want to do them at the same time or hit a few of them, that'll be coming up too. Have a good weekend. Oh, thanks. I think I got it polished up last night, so we'll see how it goes. No.